Hi everyone, my name is Brianna Gutierrez and I'm going to be presenting on the light detection and ranging approach to autonomous vehicles. I chose this topic because recently when I was applying for a job, they asked me to write a noise filter for LiDAR, and when I was researching how it works and what it's used for, I saw it was being implemented into autonomous vehicles and I thought that was really interesting. So light detection and ranging is usually referred to as LiDAR. It's similar to sonar and radar, but instead of using sound waves or radio waves, it uses light waves. It's a remote sensing method. So it measures distances by emitting lasers towards an object, and the time that it takes for the laser to bounce back is the distance it's able to calculate. There's both terrestrial LiDAR and airborne LiDAR. Terrestrial LiDAR is usually what we see in the autonomous cars and other AIs that use this type of sensors. Airborne LiDAR is those sensors that are attached to like planes and anything above the Earth's surface. It's been seen to be used on rockets. Actually, in 1971, it was used on the Apollo 15 mission, and it was used to map the surface of the moon with it. So it works by calculating the time it takes for the light to hit an object and reflect back to the scanner. And not all of them work the same. It depends on what it's being used for. So on the Apollo 15 rocket, it was being used to map the surface of the moon. But in SpaceX, their Falcon rocket uses LiDAR, but in that rocket, it's used to track its launch pad. And so depending on what they're used for, it can have different bandwidths of the precision and the objects it's looking for. And so on the right, there's an image of airborne LiDAR. So it was probably attached to a plane and it's mapping the surface of a forest, probably to collect data on the density and stuff. So once the data is collected, it transforms into what they call point clouds. And these point clouds can then be rendered into 3D models. The point clouds are just a collection of dense points collected by the sensor, and that could be an object, or in this case, the map. All those trees would be point clouds, and each point has its own GPS, so it's able to locate and calculate the distance of all of these objects it's scanning over. So in self-driving cars, it'd be able to detect people and other objects around it. And it hasn't been completely implemented into autonomous cars. It's a more recent thing. It is currently very expensive to have on cars. So someone like Elon Musk has came out and said that he doesn't support it for Tesla because it's too expensive, and he believes that cameras is what works best. But other people do not agree with him. Most recently, Volkswagen started investing into LiDAR chips to then be implemented into its cars, such as Audi and Porsche. And in test trials that we see today, most of the time it's an electromechanical LiDAR, and that's when the sensors placed on top of the car to rotate around and scan everything around the car. But it's not ideal to have that once it is implemented. The solid state LiDAR is more ideal because it's a single chip, and it works by having optical emitters which send a burst of laser photons without having to adjust the direction of the transmitter. So unlike the electromechanical LiDAR, it wouldn't have to rotate on top of the car. It could just be placed in the car. And most recently, a company called EVA created an Aries single solid state chip for LiDAR, which can also measure velocity of every point. And currently, autonomous vehicles have only autonomous features, so that makes it at a level 3. And the future of autonomous vehicles would be level 5. And for that to happen, it's best to have more data than less. And so that's why companies like Volkswagen have been investing and leaning towards more of a LiDAR approach than cameras. So noise does play a big factor in sensors, as to take into account a lot of different conditions, and also depending on what it's being used for, because it can be used in space, underwater, on cars. And so because LiDAR is so precise, it can actually detect molecules in the air, such as like rain or debris. And so some unpredictable conditions can be like rain, shock, vibration, and debris. And so that's one thing that is bad. And so for self-driving cars to be at a level 5 and fully autonomous, it would have to have little to no noise so that it have a more accurate reading. On the picture on the bottom, on the left side, that's an image of a car when there's no rain, and you can see how the lasers are able to have a greater distance. But as it progresses to the right, and rain is included, the lasers no longer have the range that they need. So right now, most autonomous featured cars have cameras that they use, and there are some benefits to using cameras. Like they are more high resolution than LiDAR, but the depth accuracy is not great at all. It has a very short range, so it can work for now at a level 3, but once cars begin to get to level 5s, this depth accuracy could probably be what switches most companies to LiDAR. Cameras are affected by sunlight, shadows, and headlights, and so that'd be another filter that they'd have to implement for the noise. But LiDAR is a lot more accurate and precise than cameras, and saves computing power. It just happens a lot quicker. On the other hand, LiDAR is a lot more accurate and precise than cameras, and so as we move to the ideal goal of fully autonomous cars, that's going to be something that most companies are going to want. And LiDAR is also saves a lot of computing power. So cameras, when they detect objects, it has to be rendered and use computer vision to learn from the images it's processing. But LiDAR is able to instantly get that data from the lasers it's emitting. The downside is that LiDAR is affected by rain, fog, and snow, and other situations that could affect the lasers that are emitting from it. So there's pros and cons to both, but LiDAR is definitely going to be a key factor in the future of autonomous cars. And this isn't autonomous cars, but I thought it was really cool how in the new iPhone 12 Pro, they implemented a LiDAR into the camera. And so the sensor is able to be used by apps to create new games for AR, or easily creating 3D models of objects in your house and being able to virtually place them anywhere. So some people that reviewed the sensor for the iPhone used it to like remodel rooms in their houses, and they use it to see how furniture could look around their house without actually having to move the furniture through that 3D model. And right now there's not that many apps that can use this feature, but hopefully soon there'll be a lot more games for AR on the iPhones. And that is all. Thank you.